Started with passing around the assignment sheet. I have posted the information for this week. So you can see it on Blackboard. The main thing we're doing this week is we're going to be dealing with the development of ionic compounds. Today we're going to look at the development of those ionic compounds simply from the ions. On Wednesday, we will look at developing, I can't remember the order, but Wednesday and Friday, we'll look at developing the name of the ionic compound directly from its formula or the formula from its name. So basically, this entire week is going to focus on the formation of ionic compounds and the development of those formulas as well as the naming. This week you will have 3 homeworks and a quiz. The homework for today is going to show up at 1 o'clock, so don't forget about it. Also, you will see that I have a variety of times that I'm available this week. So if you struggle on the first exam, I would highly recommend finding time to come talk to me. Let's figure out what went wrong. Let's see if it's something that was in how you study, or let's see if it was something else that went wrong. But let's get back on top of this, because again, with respect to the homeworks, the quizzes, the tests, you do have so many that you get to draw. But you can't become too complacent and use that, because you never know where the semester is going to take us, and it will get tougher. So, I would highly recommend coming in and seeing me at some point and us talking through what was going on. Maybe I can help come up with some tips and tricks to help you along the way. If you were not here on Friday to get your exams back, then come see me at the end of class, or if you've never gotten quiz 1 and quiz 2 back, come see me at the end of class. I've got all of your grades. I just need, basically, you weren't here the day that I passed stuff back. So, before I get into today's information, I do want to ask a couple of questions, or one question in particular, and that is style, because this is your class, and I want to approach the class in a format that is more suitable to you. We started out the semester, and I used Mentimeter quite a bit, and I hopefully will get back to Mentimeter for some basic questions, but I used it to, in a sense, see what you were learning off of the videos. But for the most part, on those, you really did have to watch the videos, because I didn't lecture much. We went straight into working problems, and that's what we were doing. Last week in particular, I kind of swapped how I was doing things, and I started lecturing more in class as well as working problems, but it does mean a few less problems to do. I need to know which one you want, which style you prefer. Just because I lecture more does not eliminate the need to watch the video lectures. It just means that hopefully you'll be solidifying your knowledge a little bit better. So all those in favor of Mentimeter and more problems, raise your hand. All those that want more stylized like I was doing last week, raise your hand. Okay. Again, I always try different things with my students, because I do want to do what is right by you. And so I will start making sure I have lecture and some material to do as examples. Any questions for me? And I don't mind if you ever have anything you need to tell me, please make it constructive criticism, because that way I can do something about it potentially. But I don't like students waiting until the end of the semester for evaluations, because once it hits the end of the semester, if I get an evaluation, I'm not going to be able to do anything about it at that point. Whereas if you're talking to me throughout the semester, there's a chance that I can do some alterations. I will say that there are some of you that need to start coming to class a little more, and that would be useful, that are missing about 1 class a week.
I haven't said much, but I have noticed. So, okay. So let's get into ionic compounds. Ionic compounds contain an ionic bond. An ionic bond is an electrostatic attraction between a cation and an anion. Basically, folks, it acts like a magnet between those positives and the negatives that we were talking about last week. The formula of an ionic compound shows how many cations and anions combine to make the compound. It does not want to be nice to me. There. Okay. The number of each ion is relative or is related to the quantity necessary to make the compound charge neutral. And what I mean by that is a charge neutral compound means that all of the positive charge is counterbalanced with negative charges. The number needed for charge neutrality is shown as subscripts. To the right of the element in the formula. Now, there are a couple of things I want to note about this. The first thing I want to note is if only one ion is needed, the one will not be showing. And the second thing I want to note about this is if working with a polyatomic, Then if more than one is needed, the formula of the polyatomic is placed in parentheses with the quantity needed to the right as a subscript. Basically, folks, you can't change the formula of a polyatomic ion just to make it have the right number of atoms. The formula of a polyatomic ion is a constant thing. You cannot change it. So that's why we put the polyatomic in parentheses with the quantity needed as a subscript outside the parentheses. The last thing I want to make note of is for ionic compounds. The cation is always listed first. That is true for both the formula and the name. Questions? I'm just gonna let everybody catch up with my writing. And then I will demonstrate how we can get to the formula given the ions. Okay. So let's make a compound of aluminum and sulfur. Folks, the first thing I need you to note is I know this is going to be an ionic compound. First thing to note, this will be an ionic compound because it contains a metal. Okay. So the first thing I'm gonna do is just show you why it all works the way it works. Then I'm gonna show you a shortcut. But I think it's important to understand why. So aluminum. Aluminum's a metal. What charge does it have? I think I heard it. +3. Aluminum is always a +3 charge. Sulfur, when it forms an ion, what charge does it have? It is a 2. But sulfur's a non-metal. So what sign would it have? A -2. Okay, so now we're going to do a little bit of algebra, and if it has to be charge neutral, our question is, does it equal 0? That's going to be what we're going to be answering the entire time. So we have a +3 that comes off the aluminum. We have a -2 that comes off the sulfur. Does that equal 0? No. So it's not in a 1-to-1 ratio. Which one do I need more of, the positive or the negative? Remember, I can't change signs. I mean, charges. So do I need more negative or do I need more positive in this particular case? Negative. Okay, so let's add another one. Now I have +3 from the 1 aluminum and I have -4 from the 2 sulfurs. Does that equal 0? No. So it's not going to occur in a 1-to-2 ratio. Which one is in the lower quantity, the cation or the anions? Not lower quantity as in how many there are, but lower in the charge. Who's lower in charge right now, the cation or the anion? The cation. So let's add another cation to this thing. Now we have a +6 and a -4. Does that equal 0? No. So which one is in the lowest supply? The plus or the negative? The negative. So let's add another one. And when we add another one, we get +6 -6. So is that equal to 0? Yes. So a compound that contains aluminum and sulfur needs to have 2 aluminums and 3 sulfurs. The quantity I said is written as a subscript. So it's going to be Al subscript 2, S subscript 3. And this is the formula of a compound that contains aluminum and sulfur. Questions about the theory behind why it combines in a 2-to-3 ratio?
So do you just have to like keep adding cations and anions until they like equal 0?
That is correct. You add cations and anions until the two sides, until the plus and the negative come out to equal 0. That's why it's called charged neutral, is because the cations plus the anions come out to equal 0. Yes. Because what's important is the charge, not the So what was important is the addition of this charge. So we have a +6 and we have a -6. It does not matter, it's not the quantity of our ions, it's how's the charge. It's all about the charge. Does that answer your question?
How is that? So, I, so I guess what I'm trying to say is, so those above +3 charges, that's how you got 6, right?
Mm-hmm.
I don't really understand. I understand.
Okay. So all this over here was just to illustrate why we had to have 2 aluminums and 3 sulfurs. The 2 aluminum adds up to +6. And if you add up these -2s, -2, -2, -2, that's a -6. So the entire, this is just illustrating that when we started out with just one of each, let's, now that you've got it written down, let me try something. Let me try redoing it. And you just pay attention to what I'm saying and what's going up on the board as I'm doing it, and see if that helps some. Because it is, a lot of people, ionic compounds can cause havoc. So what I'm gonna do is I'm gonna start from scratch. We know what it's gonna end up as. So aluminum 3+, if you simply add 1 sulfur, which has to have a 2- charge, it's always that 2- charge. When you add those 2 charges together, it does not equal 0. So it cannot occur in a 1-to-1 ratio because the charge does not equal 0. I can add another sulfur to this mix. In fact, let me do it a slightly different way. Let's play with colors so that I know when I'm adding it. Why are you misbehaving, pen? Okay, so if I add another sulfur, I still have a +3 from the aluminum, but now my 2 sulfurs are adding up to a -4. This is equal to a -1, so it does not equal 0. So it's not in a 1-to-2 ratio because it's not charge neutral. I can add another aluminum. And now I've got a +6 with that -4. And that's equal to a +2. So that still does not equal 0. So it's not charge neutral. Only when I add 1 more sulfur in here and I get the -6 to go along with the +6, do we get to 0? And that's when we know we are charge neutral. So it had to have that aluminum 2s3 just to make it charge neutral. That's the entire focus, is that charge neutrality. I don't know if that answered your question. It takes time.
So whenever you're adding them, usually, I mean, in my brain, it would make sense to start with the negative to charge. You have to go back and forth, right?
You have to go back and forth, and the way I knew what to add is right here. My negative was greater than my positive, so I had to add another positive. Here, my positive is greater than my negative, so I have to add another negative.
Let's look at another example. Yes.
And then your 2, 3, like on the ending column, like the AL2S3, that came from your 2 aluminums and your 3.
Correct. These numbers come directly from how many of each one I had to use.
Again, I'm trying to illustrate the theory at this point. I will show you a faster way to get some of it here in a minute. Let's look at another example though. Let's look at a compound that contains calcium ion and sulfate ion. What is the formula for calcium ion? It's element number 20 on the periodic table. It's a 2+ because it's in group 2. What is the formula of sulfate? The ATE tells me it's a polyatomic. ATE and ITE tell me it's polyatomics. It's a 2 negative. It's SO4 2 negative. So here we have a +2 and a -2, which does equal 0. So there is only 1 calcium and 1 sulfate in the formula. So the formula is CaSO4. I didn't need any more.
This is an example where I didn't need to add extra ions of either the cation or the anion because they automatically added up to 0 to start. And so it's just a 1-to-1 ratio. Questions?
Let's do one more. And then I'll show you the methods. We're going to do one using chromium 3+. Why did I tell you the charge this time? Because it's one of the ones that I don't know the charge because it's in the transition metals. And there's only a few elements past group 2 that we know the charge of. So I had to tell you the charge. And let's do nitrate. Again, the ATE is telling me that it is a polyatomic ion. What is the formula for nitrate? Not quite. It is NO. It's NO3 minus. It is in period 2, so it's one of the ones that only has 3 oxygens and it's a -1. So right now we have a +3, a -1, which does not equal 0. Which one should I add more of? Nitrate, why? Because I'm working towards that 0. So I'm gonna add another nitrate. And now I have +3 and I have -2, which still does not equal to 0. Which one do I need some more of? I need some more of my nitrate. So I have add another nitrate. And I get +3 -3, and that does equal 0. So this compound is going to contain 1 chromium, 3+, and 3 NO3 minuses. Yes.
So you don't have to go back and forth?
You don't have to go back and forth if it's not necessary. The only reason I did in the first example is because of
How there was a rule of like you had to.
No,
do
you
this
don't
one,
have
you
to-
do
no,
that.
you don't have to go back and forth. It's all about getting to this 0, to be honest. However you can get to 0, it's all about getting there. Now, this is where I do have to bring in one piece from up here. I told you that if working with a polyatomic ion, then if more than one is needed, the formula of the polyatomic ion is placed in parentheses with the quantity needed to the right as a subscript. In that last example, I needed 3 polyatomics. So what you're going to do is you will take your element symbol, and for the polyatomic, you're going to place the polyatomic in parentheses with the quantity needed outside. Now, before we move on, I do want to make a note of some things. First of all, reading this formula literally says I need 1 chromium atom. I need 3 nitrogens. And I need 3 plus 3 plus 3, or in other words, I need 9, if I could add, I need 9 oxygens. Questions about the meaning of the formula that we generated? Or in other words, the way to do this is a 1 because 1s aren't shown. This is a 1 because of this parentheses. That 3 is multiplied by each thing inside the parentheses. So 3 times 1 is 3. 3 times 3 is 9.
questions?
So basically, you three on that, so the parentheses only applies to oxygen.
No, it applies to everything inside the parentheses, so we had to do 3 times 1 to get the 3 nitrogens.
Oh, never mind.
And we had to do 3 times 3 to get the 9 oxygens, but it only applies to what's in the parentheses. Okay, so I told you I would teach you a way to do this a little faster. And it's the way I will do it most of the time. I was trying to show you the theory to the best of my ability behind the formation of ionic compounds. But when I write an ionic compound, most of the time what I do is what I call cross, drop, simplify. You're going to take the number in the charge and cross it to drop on the opposing ion. Then you must simplify if a set of subscripts is divisible by the same number or by any number other than 1, then you must simplify the subscripts. By dividing through by that multiplicative. And the reason for this, folks, is the ratio of cations and anions must be in the smallest whole number ratio possible. I'm going to demonstrate, don't worry. So basically we're doing the cross drop simplify method. You cross the charges, drop them on the other ion to make those subscripts, and then you simplify.
So let's go back to the one that I started with, which was the aluminum sulfide. I want to illustrate it with the ones we've already done so that you can see what I'm talking about, or at least the aluminum sulfide to see what I'm talking about. So we started this exercise with aluminum, sulfur, aluminum and sulfur. I'm going to take the aluminum and I am going to take that 3 and drop it on the sulfur. I am going to take the sulfur and take the 2 and drop it on the aluminum. So that you get aluminum 2S3. And that is simplified because they're only divisible by 1. So you take the number on the opposing ion, you're going to cross and drop it on the opposite ion.
So when you did the aluminum went across the 3 stay positive, why? So you're just taking the number.
I'm just taking the number. The aluminum, technically the aluminum is still a 3+. But I'm just showing you a fast way to get to the formula by taking the numerical value and dropping. Let's look at the, what was it? Chromium nitrate. So we had Cr3+ and NO3-. Now, anytime you see a minus or just anytime you see a plain old minus or a plain old plus, it means a -1. So we're going to take the number of the chromium and we're going to drop it on the polyatomic. Take the number of the nitrate and drop it on the chromium. So on our chromium, we're dropping a 1. On our nitrate, we are dropping a 3. And because we're dropping something like that on a nitrate, we place it in parentheses. Anything other than a 1, you place it in parentheses. And so that's where the chromium nitrate that we came up with earlier. It's just we don't tend to show a 1, so it would have been written as Cr NO3 3. Let's look at one we haven't done. Let's do magnesium and chloride. And let's do nickel phosphate. Oh, and I'm going to have to tell you it's a nickel too. And I want you to try to come up with the formulas for those in the last few minutes of class. This is what the homework, most of the homework's over. They're 2 separate problems. And I'll show you one, I'll start the class with one that we have to simplify the next time. Magnesium's group 2, so what's its charge? Chloride is a group 17. And the IDE tells me it's just an element. So what is that charge? -1. So what's the formula of magnesium chloride? Mg what? Do we need 3? That's a -1 up there. So you just need one of them. You're going to cross that 1 and drop it. No, not that. Cross that 1 and drop it onto the magnesium. So it's going to be simply MgCl2. What about the nickel 2 and the phosphate? So nickel 2 is Ni2 plus. And what's phosphate? ATE. It's in group or period 3 and down. So how many oxygens will it have? 4. And because it is in period 3 or down, the charge is the same as its elements charge. So what is the elements charge of phosphorus? -3. So it's a 3 minus. So we're going to cross and drop. Cross, drop. So what is nickel and phosphate's formula? That is correct. Again, you will have homework like this tonight. And then on Wednesday, we're going to start working with names to formulas or formulas to names. And then we'll do names to formulas. I will see you Wednesday. And if you did not sign in, please make sure you get to the sign-in sheet. Which is right here. Otherwise, you're not counted as present and you lose points. Okay. Yes, I'm not test. Come on up and I will give you your test back. Got a mess down here. And I do mean a mess. That's okay. Okay.
John.
Thank you.
There's all lot of sand banks in the sewers.
Yes, it is.
Okay.